this performance factor actually takes some things from the car, which calculates then a factor, and the classes are not displacement based, but you put some key information from the engine, like individual throttle bodies, dry sump or not, what's the maximum RPM, so it gives you a factor for the engine. Then you have like what type of a chassis you have, what kind of structures you have, what kind of aerodynamic things you have in the car.
Oh, wow.
And finally spits out this factor and 5 groups. That's where you can drive with pretty much anything.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Mikko from VHT Racing. Mikko is originally from Finland. He's actually currently based in Germany. And we got hold of Mikko because I've got a soft spot for old rear-wheel drive Toyotas, and anyone who's listened to the podcast episodes in the past will probably have already heard that shine through. And Mikko has probably the sickest KP Starlet you're likely to find. In particular, it is now outfitted with an RPE Hayabusa-based V8, producing around about 440 horsepower. It's also fitted with a SADEV sequential gearbox that's paddle shifted and runs a suite of Bosch electronics, including a Bosch ECU and Bosch Motorsport ABS. So suffice to say, it's probably like no Starlet you've ever seen before, and he uses this to compete in the very competitive European Hillclimb Championship. Mikko also works a day job for Bosch Motorsport, so he has a very, very solid grounding in Bosch's electronics products, specifically their ECUs and their ABS systems. And in this conversation, we get the opportunity to dive deep into both of those systems, particularly find out what the difference you're going to get is when you're paying literally tens of thousands of euros for a Bosch Motorsport ECU compared to the more enthusiast level products that we're used to seeing. Now, before we get into our interview with Mikko, for those who are new to the HPA Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune engines, how to build engines, construct wiring harnesses. We also cover race driver education, racecraft setup, data analysis, and a lot more. All of our courses are delivered via high-definition video-based modules that you can take from anywhere in the world, provided you've got an internet connection. This means that you can learn in the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked money-back guarantee. So if for any reason at all you purchase and decide it's not quite right for you, let us know. You get a full refund of the purchase price. If you do want to find out more about our courses, you'll find a link to our courses page in the show notes. And as a podcast listener, you can use the coupon code podcast75, and that'll get you $75 off the purchase of your very first HPA course. All right, let's get into our interview now. All right, welcome to the podcast, Mikko. Thanks for joining us today. And where are you joining us from in the world?
Thank you very much. From Germany, close to Stuttgart.
Okay, but you are in fact Finnish. So how did you end up in Germany?
Yeah, that's correct. So I'm from Finland, but been living abroad already for 10 years.
Okay.
So yeah, it's basically work, which led me to move around the world. So I've been also living in the States, and now this is my second time already in Germany. So.
Okay, well, we'll get into your work history and what you actually do as a day job soon. Let's move back a little bit, though, and let's learn a little bit about your background. Specifically, how did you develop an interest in cars and motorsport?
So, coming from Finland, rally is really big. And actually, my father and uncle, they used to do rallying when I was a really small kid, as far as I remember, and even seen in the pictures, I was just like a few years old in an Hillman Imp being repaired after a crash, playing around there, and then being always around rally cars in service. It was also in the 80s and also in the 90s, really common. Like there was so many people on it, so it was almost like everybody I knew had something to do with rally. If we weren't in a rally ourselves, then we were helping somebody doing service and so on. So that's where it really all started.
What is it about Finland specifically that breeds so many successful competitive rally drivers? I mean, is it sort of the fact that you come out of school learning to drive sideways around roundabouts?
Yeah, I think it's a quite common question being asked a lot from the rally drivers. I guess I can reflect to the fact that we have really nice roads. I mean, Finland is fairly large country. There's only 5.5 million people, so we have a lot of back roads where you can, drive around, and not anymore so much than it used to be in the past. But also in the winter time, you can make a little circuit on ice on the lake or sea. And yeah, I mean, you get the handling because you're driving in summertime on these gravel roads, very nice, winding, hilly little jumps and things, really fast, slow. There's everything there. And then in the winter time, you do the same roads, plus you can go to ice and practice there. So you get the car handling, and I guess you can learn to read the road and really handle the car. So maybe that's something which is quite special. But I mean, it's the same in Sweden. I would assume Norway also has maybe a little bit different landscape, but maybe that's Finland is the best of all.
Well, it sounds like you're basically predisposed to a life of racing cars, and it sounds like specifically rally was an obvious choice. You've sort of gravitated towards hill climb, and I mean, there's some elements of rally in that anyway, but the hill climbs that you're competing in are sealed roads, tarmac roads. Why did you go that way instead of traditional rally?
Well, I did rallying. I actually did the national championship in the Group F with my car. That was where I built the car originally. It was a rally car, and I did rallies. However, then rally is something where you really need a team. You need more people in the service. If you really want to do it properly, it's actually quite expensive. So,
Sure.
and because my father, he was really into rally sprints, exactly for this reason. So rally sprint has a bit more open rule set. So the cars do not need to be street legal, or not able to drive them on the street. So you can modify them more. And then these are also kind of the hill climb format, but because there's not so many hill climbs in Finland, we call them rally sprints. And this was something what I saw really interesting, because the machines were like the same thing as in hill climb. You have such a variety of home built, really fast cars, and you could put a bigger engine in a small chassis, and it was way more open. So I guess that was the initial thing. And also there was those few hill climbs in Finland that I really, really liked. Always, we went there many times. So this was something I knew as a concept. Of course, I never thought about I would later maybe, let's say, specialize in hill climb. But yeah, that was the thing. I did rallies. Then when I had a bigger crash, I went to university, got my studies. I had no time, and then eventually I wanted to rebuild the car after it has seen quite a bit of rallying and a few bigger crashes, and I rebuilt the car back into the, let's say, the Group F regulation in Finland. But that was also the time when I went first time to drive time attack, so a little circuit racing in Finland, and got exposed first time to driving on a circuit in tarmac. And then I realized, okay, this is also actually quite fun. So I thought, okay, now I have a rally car and I'm driving around here in a circuit. It was just a one, I don't remember even the reason, but somebody asked, hey, you should come over to try it. And I was like, okay, I just got some slicks, or no, I think they were even semi-slicks from somewhere, and went with the gravel suspension. And, there it.
So not an ideal setup for circuit racing.
No, but still what I liked was the fact that I can just tow the car with the trailer there basically alone, and then just drive and enjoy and take it back. And the risk for crashing, completely totaling the car, was much less. So that was maybe also something at that point which I appreciated. So
Definitely. Let's roll things back a little bit. I want to talk about the skills that you've built up and what your sort of process of doing that was, because we've just talked off air about your skill set, and it seems like there's maybe not a lot that you can't or don't do on your own cars, which is rare. Everything from tuning, calibration work through to building your own engines, fabrication, and even the panel work. Getting such a broad set of skills that can be tricky. So how did you develop those skills?
For me, it was always the working with the cars. I had an interest really to learn the things. It started before cars, actually, already with mopeds and tuning the little moped engines. So like the 50cc little Suzuki engines and so on. So that's kind of where I got the first, let's say, hooked in the technical side of the things. And then later I got a chance after high school. I was thinking, okay, what should I do? Where would I like to go? What's like something I would be interested in? And then I found out that there was in Finland at that time a vocational school. Yeah, vocational school, sorry. So they offered like this race car mechanic study program. It's basically like a 3 years of typical car mechanics plus then some specialized things in race cars. And there I got my mechanical skills, welding, fabricating. That's where I built the chassis for the Starlet originally. That was the little project that I did.
That's it's quite mind-blowing to me, coming from New Zealand, to hear that you've actually got access to a race car mechanics course. I mean, that would have been an ideal route back in my younger days, but we just don't have access to anything like that here in New Zealand. But I mean, from all of the people I talk to around the world, that's the first time I've heard of that specific course. So it sounds like it is quite unique. You're quite lucky that you had that opportunity.
Yeah, sure. And I mean, it doesn't exist anymore in Finland either. It was only a few years, and I was really lucky to get into it. And the second year of the course that I was part of, we didn't have any funding or bigger project from the school side, so I was able to work on my own. So I just got the empty Starlet chassis, and then started fabricating and welding a roll cage, doing the modifications I had seen being done for those rally cars and what my father had done past for his, and so on. So that's how it all started then, really, to go into the fabrication and building a complete race car.
Okay, so fabrication is definitely a large element of working on modified cars, race cars, etc. I can get that they would be teaching that. That makes a lot of sense. But how about the engine building side of things?
Yeah, so like I said, the mopeds were really the thing where I first got into the two-stroke stuff. And eventually then, before this rally car project, I already had built with my father some engines for my street cars. So I've had quite many Starlets actually. And the first, when I got the driver's license, I had a Starlet which had really, really bad engine, and we rebuilt that. And then later I found a little, a lumpy cam with some exhaust and things I put in there. And then that's where it really then started. And then, in the school also, I was able to access machines and things like I was able to do my own cylinder head. So basically put some new valve seats and cut the seats and port the head. And we even had a flow bench there. So
there really is nothing that you can't do.
Yeah. So
you're even actually doing your own engine machining.
Exactly, yeah. So that was really great. So because that's part of in the early days and in the past, maybe I'm not sure if it's anymore that much, but especially in Finland, we used to rebuild a lot of engines, and it was part of the standard mechanic studies to know how these things are done and work. So,
and I think to a degree, some of those skills are maybe being lost a little bit. And I'm not trying to beat up on the current crop of mechanics coming through, but I mean, the reality is that these days, I think current crop of production engines are much more reliable than they were in the past. less service items. Cam chains have replaced cam belts. There's not a lot of mechanical work, or not as much mechanical work required, and a lot of it becomes diagnostics of electronic systems. So I think, do you agree that maybe some of those general mechanical skills of rebuilding engines is sort of getting lost a little bit?
I definitely. And I think it's a problem nowadays. Younger people, they think, okay, I want to do a work where I can, work with my laptop, diagnose, do things, and do like manual labor work is not that exciting necessarily. So,
yeah,
and even like people in the age of like when we got into mopeds and things, now it's cell phones, games, PlayStation. For us at that time, it was freedom. When we got the mopeds, we were able to drive around and then figure out who could make it go fastest and race around with them.
I'm going to come back to this moped thing because it's been mentioned too many times already not to dive in a little bit deeper. So let's just park that for a moment.
Yeah.
One of the elements that I quite often get asked about is, do you have to be a mechanic in order to be able to tune an engine? And we're going to get into your tuning as we go through this conversation as well. And the answer I always give to that is, no, you don't have to be a mechanic. Absolutely not. The two skills sets are different, but I also see there is a big overlap. And I think my own background, in learning how to build engines, basically understanding the inner workings of the engine and all of the other electronic subsystems that are in the car, what that did is that when I was tuning for a business, for my work, most people think that you get a car in, it goes on the dyno, you tune it, it leaves, job done. But the reality is, I think that happens maybe 1 in 5 or maybe even 1 in 10 times. And the other cars, there's going to be something's going to be wrong, and you're going to have to go through a diagnostic process to try and figure that out. And again, while it's not absolutely essential to be a mechanic, I think that skill set of all of that understanding in the background helps you when you get one of those engines that's not quite running right. Instead of trying to fix it with a laptop, you can actually look at the bigger picture and understand, well, actually it's got a misfire. Oh, look, the spark lead is hanging off for number 4 cylinder or whatever that may be. So I think, there's definitely some benefits in those sort of two skill sets, mechanical and tuning. Do you agree with that?
Yeah, definitely. I agree fully what you just explained. I can see that when I have good understanding on the fundamentals. I understand the engine. If we need to troubleshoot, even in like professional motorsport, there's so many times these cases where something goes wrong and you quickly need to figure out the problem and find a solution. That's really where it helps, where you understand what kind of issues can be, let's say, electrical, what can be mechanical, what a mechanical problem could possibly be, where it could lead into such situation, and so on. So I think that's really, really, for me as an engineer working in professional motorsport, that I have this background, that I also understand the engine fundamentals. It's priceless. It's really valuable.
I'll actually add to that as well. We've talked about the sort of correlation or overlap between tuning and mechanical, but we have the same overlap that exists with auto electrical. And again, I think it's really important to have at least a fundamental understanding of the electronic subsystems in the car, because the other issue we so often see on the dyno is a sensor fault or some kind of wiring gremlins. And again, while you don't necessarily need to be able to wire a car from start to finish in order to tune it, having that basic understanding so you can diagnose when maybe your map sensor or intake air temp sensor is not reading correctly, being able to fault find and figure out what that is. I think that's another really powerful skill set that every tuner should have some understanding of.
Yeah.
Let's get into your work background, and what you've talked about this vocational sort of course that you did in race car mechanics. You've also got a background in engineering, so talk us through that.
Yeah, correct. So after the vocational school, I was thinking again, like, what shall I do? Where can I find something interesting? And I had learned about building a race car working with the car, the mechanic side of it. Then I did I did actually work a little bit in a workshop and realized that, okay, maybe, it's not that interesting to work in the shop, changing brake pads and discs, or like troubleshooting some emission things and so on. I was like, okay, I need something more. And I was always really interested in the electronics. So I wanted to understand how the ECU works, how the modern car has all the sensors and the things, and it can do some nice things. So this was then something where I thought, okay, automotive electronics. There's actually a school in Finland which offers a Bachelor of Science on automotive electronics. So it's like a combination of mechatronics and software engineering and mechanical engineering. So it takes these things, puts them together, and then, I was in the first course, or how do you say it, when you start? That was the very early phase of the whole thing in the first year. That was again something where I realized, okay, now I can learn more, I can do more, and that was just feeding the interest on the things.
Sure. I mean, what I'm hearing so far is that Finland has some exceptional educational options if you want to become a race car engineer. I mean, that's ideal. You've gone from one really cool course into another. How's that panned out? Sort of once you finished that course, what was your sort of work that you jumped into from there?
Well, maybe I need to still explain a little bit more what happened during these studies, because Helsinki Polytechnic, so it is also being for a long time in the Formula SAE Formula Student as a part of there's been a Helsinki team for a long time, and that was one of the reasons why I wanted to go into the school, because I knew they have this project. So I wanted to be part of the Formula Student project, and then the automotive electronics side was the thing where I had interest in. That together was then the combination where I got to go around the world a little bit. We went to the US for the Formula SAE. We went to England for the Formula Student several times, to Germany, and so on. So it was a chance to travel around and see a little bit outside of your backyard in Finland, what's going on in there. And that was really, really a life-changing experience. I knew, okay, there's also things, very interesting things that I can't necessarily do in Finland. I wasn't right away after graduating. I wasn't applying for a job outside Finland, but I could not really find anything interesting, because I had seen a little bit the motorsport. I had seen working abroad. I had seen, again, more things you can learn and do. And then, I ended up actually starting my own company at that time, right after I graduated.
Okay.
So that's when I then couldn't find anything really interesting. I had a friend who was tuning cars, where he was doing some turbo kits, typical kind of things. I started helping a little bit, and then that was the beginning.
Just backing up one step, the Formula SAE, and people who have been listening to this podcast from the start, I would say, maybe 50% of our guests have gone down that path, starting with Formula SAE. So I guess for those listening, thinking, maybe they're a bit younger, thinking, what am I going to do to get into motorsport? And this does just come across as a continual theme that pops back up, is that Formula SAE is such a good stepping stone to a career in professional motorsport. So I only wish that we'd had access to that when I was going through university, but definitely it wasn't a thing here in New Zealand, unfortunately. I think it is now, but just keep that in mind if you're thinking about a career path. It seems to work out pretty frequently. In terms of what you were doing there with the electronics engineering, what specifically did you do on the car? Was this a case of designing the electronic system? Was it wiring? Was it installation and calibration, or all of the above?
So we didn't have that big of a team, so the responsibilities were quite wide. So I had responsibility over engine and the electronics package in the car. That's how it started. Well, obviously you get into the project when you have still the let's say the car that the previous years had built. You get into it, you start understanding what the car is, the rules and the things. And then when we started building our own first car, so then I was responsible for the electronics, including ECU, building a little steering wheel display, making an electronic clutch, which was incorporated together with the ECU and the steering wheel with all the controls and things you adjust. And then finally, also, I was the technical manager, so basically responsible for the technical side of the project. But that was then later. So engine, electronics.
Okay. And who was dealing with the calibration of the engine once all the electronics
I was
were
also
installed?
responsible for the calibration. So yeah.
You're doing that too. Okay, so on that note, and this is another question that pops up quite often, is how do we learn how to tune? I mean, obviously High Performance Academy has made a business around teaching people, but I mean, outside of that, obviously that's not the path you use to learn how to tune. I didn't obviously have that resource when I was learning to tune, and at least as far as I'm aware, that's not something that you can go to a polytechnic, a school, a university and get taught. So how did you put those skills together and develop them?
Yeah, well, it was actually exactly the need. We needed to calibrate the engine. There was in the previous car, there was a little standalone system from a Finnish brand called Hestek. Then I knew, carburetors. I used to have carburetors in my race car. I knew what it means to tune carburetors and basic things like air fuel mixture and like setting the jets and the tubes and the things on the carburetors. And then obviously as a young engineer student, I was really, really keen on getting my hands on the laptop to be able to, adjust the fuel table and the ignition directly from the keyboard, not anymore from the distributor, setting up some, counterweights and springs and things like that. So yeah, it's basically, I knew already what I would need to do. I just had a new tool to do it.
Sure. Now, we did say that we'd come back and talk about the moped side of things, which is a pretty interesting story. So you mentioned there it was a case of figuring out who had the fastest moped. And I mean, just like anything, if you've got the ability to race someone else, you're going to do it. But mopeds, it's a pretty bizarre form of motorsport, but yeah, what were you learning tuning on these engines as well? I think you mentioned 50cc two-stroke.
Yeah, so and it wasn't really officially racing them in any race series and anything like that. In Finland countryside, if you want to go somewhere or even in a city, we didn't live in a countryside, but you have very big distances, and if you want to be able to move around, you need a moped. 15 years old, you can drive with a license,
okay.
A moped. So everybody got a moped, and then obviously, they were like 50cc. Top speed was like 45 kilometers per hour. I'm not sure if it's 50 nowadays, but that was the official limit. They were sometimes they were gear ratios or things, some restrictors somewhere that they don't go faster. And then obviously we started like tweaking out what can we do with the two-stroke tuning, the basic things first, a little bit with the piston to change the opening times, and then going for bigger. Even we had 80cc cylinders, some Suzuki RM cylinders in the little moped frames, and they were ridiculously fast.
So the big block of moped engines.
Yeah, exactly. Some 24 millimeter Mikuni carburetors or Delortos, and some really nice exhaust from Malossi, and we went over 100 kph with this little moped.
Yeah, okay, it's a hot rodded moped for sure.
Yeah.
All right, I'm guessing all of those skill sets you can start to see coming together. Let's move forward a little bit, and at the moment, as I understand it, you're working for Bosch, and more specifically Bosch Motorsport. Can you tell us how you got your start with Bosch?
Like I said, after I graduated, I started working with my own company a little bit, doing projects here and there. And suddenly I got a call one day from a number. I was like, okay, what's going on? I think I know the number. And then it was a guy from Bosch in Finland, from the automotive aftermarket. He was the contact that I had during my Formula SAE final thesis for the
Right.
ECU related things and traction control. I got some contacts from Bosch at that time from the school to ask for technical support and advice, to talk with somebody who knows about these things. So then I got contact in the Bosch in Finland. And then they had followed a little bit what happened with the Formula project and proposed that there would be a position possibly open, would I be interested in? So that's how I got originally to Bosch, but it was automotive
So
aftermarket.
yet again, Formula SAE for the win.
Yeah, exactly.
All right. So what did that position at Bosch look like to start with, and how has that progressed? Because as I understand it, you've been there now for a good number of years.
Yeah. So I mean, it was interesting. It was not that the I mean, the situation around in the world was really bad at that time, and in the 2007 when I started. So I was thinking, okay, I will really need to, if I continue with my own business, I need to invest some money, and the times were not that great. There's anyway customer base in Finland is small and so on, and if you get a chance to work with a big international company like Bosch, I thought, okay, maybe the position in the automotive aftermarket was not the most appealing, but I thought, okay, let's have a look what I can learn again, new things at Bosch, and that's how I then decided to join.
What does your sort of day look like at the moment at Bosch Motorsport? What are you specifically dealing with, and what projects are you working on?
So I have my customer responsibilities. The last, let's say, 2 years have been really, really busy. We have new projects. We are talking about things like GT projects, rally projects. LMDH is also something which just launched last year. It's keeping us busy. So depending a little bit on the customer, it may be planning something for a new project or supporting a running project with some calibration activities like ABS topics or engine calibration. It really depends. There's no two similar days.
Okay, well, I guess that keeps it interesting. Well, let's talk about a couple of elements there that you just mentioned. So, first of all, the ABS, which is a topic that's of interest to me, just given that we are at the moment sort of 2/3 of the way through Bosch Motorsport ABS installation on our own Enduro car. So in terms of, like, let's start with a high level view. How does the Bosch Motorsport ABS differentiate itself from normal road car ABS?
So obviously, with the aim of the system on a road car is to allow the car to stop manner, so you can still steer the car and let's say keep it on course. It's not really optimized for braking distance or performance. Driving on a racetrack. So the requirements are completely different for a road ABS and a motorsport application. So in the motorsport application, we want to really take the full potential of the car's performance on straight line braking, turning, take everything out of the tire available, make the car stop as fast as possible, but still to be able to, let's say, overtake, brake in another clean part of the track where you may have different grip, different conditions, things to help and keep also the drivers safe in this way, but still the performance obviously is the key in motorsport.
And the other element there as well, which we see, I mean, obviously, when you're talking about GT racing, you're talking about a purpose-developed race car, not a modified road car like we see at grassroots. But grassroots style modified road cars that start life with a factory ABS system. What impact does modifying every other element of the braking system have on factory ABS? So what I'm getting at here is, we go and bolt on a larger diameter wheel. We go from a road tire to a full slick. We fit different diameter brake rotors, go from a 2-piston caliper to a 4-piston, these sort of modifications. And then obviously there's the brake pad compounds themselves, which are suited to race application as opposed to road. So when you're making so many across the board changes to the braking system, how does the factory ABS unit react to that? Can it keep up, or does that put you at a disadvantage again, even over a stock ABS system and stock braking system?
It really depends. If it's a true performance car from the beginning, not just a grocery shopper, the ABS already may have some different approach on the calibration. But if you really put different tires completely, you put so big brakes that the car's deceleration capability, the whole car, the chassis, suspension, kinematics, everything has been tuned, and the performance has been, let's say, from a stopping distance, you go much shorter. You can decelerate from, let's say, with street tires, with a performance car, like 1G, you go suddenly somewhere to 1.5, 2G of deceleration. The whole ABS vehicle dynamics model, which is built in, is not functioning properly, and the tire may have a completely different operating range for, let's say, the slip, optimal slip. It may be that you can have much more, let's say, longitudinal and lateral capability in the tire, so that to take advantage of all that. So the street version, the road car tuning, is again, like said, for safety and originally calibrated for that car as it is. So quite soon, usually, I think you notice that the system is holding you back, so you can't really take full advantage of the rest of the car and the brake system.
I think most people listening could probably understand that when you're making all these wholesale changes to the braking system, you're so far out of the ballpark from what the factory ABS calibration was designed for that it's almost guaranteed you're going to have some level of compromise. The other element is, you mentioned there, it's going to depend on the specifics of the car. And I've driven some cars with factory ABS on a racetrack, modified cars on a racetrack, where the factory ABS was actually exceptionally good. Maybe not in comparison to proper motorsport ABS, but it worked and the car was effective. And then some other cars where essentially you learn very quickly to stay out of ABS actuation because it's so detrimental to the braking performance of the car. So I mean, it's very much on a case-by-case basis. When you move to a professional ABS system designed and calibrated for motorsport, like the Bosch ABS system, you basically then provide all of the information about the car that's required to Bosch, and they will do a base calibration for the ABS unit to suit your car. Is that correct?
Well, there's some parameters like you need to give on the standard vehicle data sheet, as we call it. So wheel circumferences, some weights, and some things like, is it a rear wheel drive, front wheel drive, and so on. So these basics you need to give. But every unit, like Club Sport or the standard kit, they come out with the same calibration. So basically what you have in the 12 position switch as positions is always the same. So you just need to give some standard base parameters for the system to work correctly, and then the calibration is the same.
That 12 position switch that you just mentioned, this is sort of an element that we see with the Bosch Motorsport ABS installations. Can you give us an idea of what the different positions actually do, what they affect, or how they affect the ABS operation? And I guess the next question that goes on from that as well is, as a driver, how do you find the optimal switch position?
Sure, yeah. So obviously we try to cover with the 12 positions as many applications as possible. So there's a range from, let's say, dry to wet, as you see it in the sticker in the position switch. So it is a little bit of a directional thing for a really bad grip and a good grip. And if you go through the switch positions, you will find that the car behaves possibly different way. So it's kind of like a linear range, but still there are some things for, let's say you have an application where you have front mounted engine rear wheel drive, you have a front wheel drive, you have a rear wheel drive with an engine on the back, and so on. So these things we try to cover because we deliver, like I said, the Club Sport kits and the standard kits for normal customer. If it's not a tailored OEM project where we do specific calibration for that car, we sell all the kits with the same calibration. So we try to cover that everybody finds a position which works for their car. 12 positions, it's actually quite a lot. So usually you can find, and it depends on so many things, but I would say that sometimes you can get 70%, sometimes 90% of the performance already with those positions. And then you have dry and wet, and you can find something for each conditions and something in the middle if you like.
So I mean, ultimately, there's an element of adjusting or finding the position that's going to suit your specific car with what is, as you mentioned there, a generic calibration. However, I'm guessing as well, you sort of mentioned that sticker's got dry and wet. So this is going to be a constantly moving target, because as the track conditions change, if you've got a dry track versus a wet track, the optimal position is going to change as well. Maybe your tyre degradation as well. Well, these things will all affect what the optimal ABS setting would be.
Sure, yeah. And I mean, you kind of mentioned it already earlier, what I catched, but we didn't talk about it. So when you use that street ABS on a modified car and you try to stay out of the ABS, so your threshold braking then basically, so with the least grippy wheel, basically, the tire which has the least grip, and your threshold braking on that. With the Motorsport ABS, the goal is that you can brake completely so in ABS that all the wheels are in ABS control. And this gives exactly the performance gain when all the individual wheels are controlled into the optimal slip and the wheel dynamic. And to really, let's say, fully utilize this, sometimes you need to start trusting the system. And then again, like I said, you need to have a switch position where everything fits, so that it fits that tire, it fits that car, so that you're not overdriving the tire or under braking because of the calibration. But eventually, when you have a really good calibration, then there's no way a driver can outbrake the ABS. You only have one brake pedal, and the ABS basically has four. So
yeah, sure. So a couple of elements, so I just want to dive into a bit more detail there on now. I'm not speaking here from personal experience as yet with the Bosch Motorsport ABS, but as part of the installation, we've kind of been trained up, I guess, by Bosch Motorsport in Australia on some of the technical elements. And one of those is the driving style, which you kind of just alluded to there. And they've actually had a lot of trouble with drivers coming from race series where the cars have no ABS, so they're used to that threshold braking, basically finding that point where you're just getting onto the initial lock up. So obviously that's the limit of how much you can brake, and they jump into a car with Bosch Motorsport ABS and try and apply that same sort of threshold braking style. But from what I've been told, with the Bosch Motorsport ABS, the driving technique in a hard braking zone is essentially you want to treat the brake pedal like a switch and hit it as hard and almost as fast as you can. And the reason behind that might sound a little bit counterintuitive, but the reason behind that is obviously that's going to then run you into ABS actuation. You're going to have all four wheels with the ability to lock. But because you've got so much pressure there on the pedal, the ABS unit can only bleed off pressure from the caliper to reduce lockup. It can't add pressure, so you need that excess pressure reserve from the pedal, so that when the lockup is stopped, more pressure can then be sent to the caliper and then essentially relock that brake. Now, I don't. Maybe that's the worst explanation I could have given, but does that make sense? Does that match reality for what you see?
It makes sense. So you need to reach the locking pressure on all four wheels, not, for instance, only the unloaded side in the corner if you're trail braking or so on, but always the locking pressure on all wheels, and you have to maintain it. So obviously there are corners and places where you don't need to brake on the ABS. You just set the car, slow down a little bit. You're not need a full ABS braking, but some really hard braking zones, the really fast application gradient to get into the locking pressure as fast as possible. Also, to take the whole initial deceleration is when you still have high speed. Also, the aero loads and things like that can affect, so you can brake also much on the rear axle in the beginning and so on. So you want to go early in the activation, and then the ABS stays in control, and you just have to stay hard on the pedal. And actually, what you feel in the pedal then is eventually when the ABS needs to pump the fluid, or let's say it releases the fluid from the caliper to reduce the pressure, and blocks the line from the pedal master cylinder into the caliper. And then there's an accumulator which fills where this pressure can be really released quickly. And when the accumulator becomes full or almost full, then you need to start pumping the fluid back. And this is then what you feel on the pedal. So the continuous ABS control, you will then obviously feel the pulsations in the pedal too. And this is sometimes which scares people. So if you haven't driven with a proper ABS system, they kind of find the threshold where it starts to activate and work a little bit, but then they bleed off quite quickly. And yeah, there you lose already performance there. So when everything is properly calibrated and set up.
The other element with the ABS system is the brake bias. Now, conventionally, most race cars will run a pedal box with an individual master cylinder for the front and rear circuit, and we've probably all seen the adjustment knobs that'll be on the dashboard somewhere, so the driver can physically adjust the brake bias between the front and rear axle line to optimize the braking. And now that's always going to be a bit of a changing target as well, depending on tire degradation, track conditions, even fuel loads, etc. Your brake bias is also definitely going to need to change more rearward on a wet track compared to a dry track. So when you've got an ABS system, I mean, a lot of people kind of would assume that the brake bias is less relevant, because if you lock a rear wheel, obviously the ABS is going to unlock that. But from your perspective, is the mechanical bias, that base mechanical setting of the front to rear brake bias, still very critical for the operation of the ABS system?
Yeah, for sure. Like I said, there are plenty of occasions where you brake so that you're not fully going into ABS. You might just have one wheel in control and so on, and the base brake system and the bias and the drivability has to remain. So that's definitely still important. But let's say if I'm working on a project where I see continuously that the front is in ABS control really quickly, the rear basically starts to control really late on a downshift, maybe triggered by a downshift or something like that, and then you still want to beginning both axles, front and rear, from the early phase of the brake application. And again, it's just lost performance if you're not using the rear tire completely on the braking.
Yeah. As I understand it as well, one of the parameters that the Bosch Motorsport ABS actually gives you is a suggestion of the mechanical braking bias. So you can use that feedback to help adjust the brake bias setting.
Yeah, that's correct. There's an indication of the bias on the CAN messages coming out of the ABS, where you can see a few different methods of giving the recommended bias. So that's a good indication. It can give you direction.
I just wanted to take a moment out of our interview with Mikko and talk about a special package deal that we've got that's going to be perfect for the motorsport enthusiasts out there who have a real thirst for knowledge, and that is our VIP package. Our VIP package gives you access to every single course that HPA currently offers, and that is a very extensive list covering engine tuning, engine building, wiring, race car setup, race driver education, fabrication, 3D modeling, and CAD, just to name a few. On top of that, once you purchased VIP, you will get free access to every course that High Performance Academy ever releases in the future, so you will never pay for another course. Access to all of the current courses at the moment alone totals $4,397. You're also going to get lifetime access to all of our members-only webinars and lifetime access to our forum, which is the best place to get reliable and trustworthy answers to your specific questions. As a thank you, we're also including an HPA t-shirt and sticker pack. We'll ship that out to your door. The VIP package is normally valued at $2,197. This alone represents amazing value for money. The total value of everything included is about $8,500. I know it's still a lot of money. We do offer some payment plans, and as a special deal here as well, you can use the coupon code VHTRacing300. And that will get you $300 off that purchase price. So this is an amazing deal. We'll put a link to that coupon code and this package in the show notes to make it really easy for you to find. Let's get back to our interview now. All right, let's park the ABS side of things and talk a little bit more about the Bosch engine control side. And this is, an element that we don't see too much outside of professional motorsport. I think probably an element of that is the cost. From what I understand, Bosch Motorsport ECUs can be cringingly expensive. Do they have entry-level products that would suit grassroots and sort of club-level racing, or is it really just restricted to that upper echelon professional motorsport only?
Well, yes and no. So it's completely true. Like Bosch as a brand is top-tier projects, high-level motorsport, and maybe customer racing programs, not club level. But like on the recent years, let's say the last 5 years now, when the MS6 ECU family came out, there's actually also an entry-level ECU which is not that expensive. So if you buy it with the just with the basic things for a port fuel injected engine, it's not that expensive if you compare to some other things like Motec, Mtron, whatever, Haltech. So it's not that much more.
Okay.
And
so it's in that same sort of price point vicinity.
yeah. And there's even nowadays, we call it as a base software. So you can do a pretty complicated application already with the base software. So
When you mention base software here, and again, I haven't had first-hand involvement with the Bosch Motorsport electronics, but as I understand it, if you're doing a project for an OE building maybe a new GT3 car or something of that nature, the firmware or the way the ECU works is kind of custom tailored to the requirements of that particular application and the OE manufacturer. Is that how it works?
yeah, that's correct. So quite often there's requirements in the, let's say, the whole chassis side, the integration, that some things need to be adapted. Not necessarily even the base engine controls, like we have the Alpha N and the PN system on the background, and like everything else is okay. You can do up to 12 cylinders. Most probably, usually that works already quite well for like a GT3, GT4 project, GT2, and then sometimes you have some requirements from, let's say, Gearbox. You have some other things on the chassis side that the customer wants to make work in their car. And then we either do custom software firmware for the customer, or we also have the CCA in the ECU, so it's possible to run the Bosch partition and the customer partition in the same ECU. So you can, for instance, have access points in the base software where you come up from you have a traction control which is built on the CCA, the customer code area side, and it has then some entry points to the software in the Bosch side. Where it comes to the torque control, you get access to wheel speeds or slip calculation things you can use as they are, and then you can do your own control strategy and then feed it back into the, let's say, the Bosch side of the partition. So there's two ways. We either do custom software or the customers will do their own software on the CCA side.
All right, so just to clarify that, so customers can essentially write their own firmware in what you mentioned there is CCA, customer code area, is that right?
Yeah, that's correct. So it's actually Simulink. Okay. It's all Simulink. So you get just a environment where you can work in Simulink. You do your own control strategies, and like I said, you have the Bosch part of the software, and you can compile then your own software.
Right. So it sounds like if you're capable of writing that code, it would be a very flexible unit.
Yeah, that's correct. And that's, I think, how it all works. We have the ECU has also the logging capabilities. So MS6, for instance, is really the four versions, the PFI and the GDI versions. If you look at the GT market at the moment, I think as most projects are with our electronics.
Obviously, Bosch is known for producing ECUs for OE applications as well, outside of this motorsport. You know, we've just released a WinOLS course, and part of the worked examples that I added to that, we've got one on a Mark V Volkswagen Golf, and clearly that's an older vehicle now, but that runs the Bosch MED 9.1 ECU, and I'm literally in the process of doing the same on a 2011 4.2 litre twin turbo V8 diesel Audi Q7, and that runs a Bosch EDC 17. So how much overlap in terms of the technology that goes into developing factory produced OE engine control units, how much of that crosses over to the motorsport range? Is it basically the same ECU but with an interface that allows easy calibration by the end user, or are they quite different?
Yeah, it depends. We had in the past some ECUs which were based on the production ECU, where it was then only software was for motorsport, but the hardware was production. But now if you look at the MS6, MS7, they are designed and built for motorsport. The MS6 uses a production housing and a connector, but the circuit board itself is nothing to do with production. It's a pure, proper motorsport design and developed for the motorsport applications.
Okay. Now, just so our listeners can kind of get an understanding, I'm interested in what you see separates the likes of the highest end Bosch Motorsport ECUs, which I hear numbers thrown around, sort of 10,000-20,000 euro for an ECU. I don't specifically know if those numbers are correct, but you can let us know. What separates that style of ECU or that price point of ECU from what we are more used to at the enthusiast and club level of racing, and the Motec, the M-Tron, the Haltecs that you mentioned?
Yeah, so for me, it was always about the way how the engine speed, positioning, the precision, the reliability, how the software, I mean, it is a motorsport ECU. The hardware is for motorsport, but we have engineers and engineering behind from many, many years, decades of making engine control units. So these basics have been then honed, and now what you see in the software is not all. So there's still a lot of things on the background. So everything what comes to, let's say, reliability of signals and, like said, the engine speed evaluation and positioning and the precision on the ignition and so on. So I've never seen anything like this in anything else. So no matter how bad, sometimes you're just wondering how it can still run basically with the ECU, and it still runs reliably. And if you have any problems, there's things which are happening. I mean, obviously we have the logging now also in the ECU. The logger is really, really capable. So what you can do is with the logging is just, if I compare to any other products, I don't think any one of them offer the similar kind of, I mean, there's Pirelli, Cosworth, there's McLaren, and so on. So these ECUs for sure can also, but then they are not the entry-level club ECUs either. So
No, exactly. I mean, obviously Bosch is not alone in that higher price point market at professional motorsport, but I just wanted to get that sense of, what is the separation between our kind of enthusiast market and this professional market. The element that I'm interested in here as well, I mean, physically running the engine, delivering fuel and delivering spark. I don't want to downplay this, but that side of things is relatively straightforward as I see it. The precision that you mentioned, that's definitely an element that's easy to overlook. So I get that side of things and the importance of that, particularly as the engine output climbs, the tuning envelope becomes narrower. So making sure that the ignition timing and fueling is always accurate is critical if you want good reliability. But it's the ancillary functions, I think, that there's often more of a separation between entry level and professional level. And so what I'm talking about here is things like gearbox control, traction control, some of the safety parameters like knock control. Do you sort of agree with that sort of stance, that these are some of the more important things, that while we've got an entry level ECU that has traction control, the way it actually operates and the functionality versus Bosch Motorsport ECU with traction control, it's quite different?
Yeah, that's correct. Another aspect is the hardware itself. So if we think about our requirements for the ECUs for vibration, temperature range, everything, we have applications in Rally 1, for instance, where it's extremely high vibration, and these ECUs have been, let's say, developed and tested in a way that they survive in the most harshness conditions. So this is also something. But yes, also then for the more advanced functionalities, I would say that the typical club level systems are more simplified. They can be calibrated quickly. Sometimes our functions are derived from the production, like the knock control, what you mentioned. It's not something which you can simply tune on a chassis dyno with your knock headphones or a tube in the engine block and coming into your headset. And so you will actually need to do proper knock application, where you have cylinder pressure sensors, you have the very high speed data logger to log the piezo sensor signals, and then compare to the knocking signal, and make all the filters and your measurement windows, starting positions and lengths, and there's so many different filters also you can choose in the ECU, and this is also from the production. So it comes from the experience over many years in production, how all this works.
So I mean, that straight away also highlights a big difference in the development and tuning process between what we do at the enthusiast market and what's being done at professional or OE levels. I mean, just simply purchasing an in-cylinder pressure monitoring system is horrendously expensive, and then there's the complexity of actually adding that into the engine. So that's before you can even get that data and start using it. So obviously, from what you're saying there, the calibration process is going to be a lot more lengthy, a lot more involved, and hence a lot more expensive. So it's not just the cost of the ECU that you need to factor in. But of course, when you're dealing with OE manufacturers with a GT program, they've got the necessary financial resources, don't they?
Yeah. And, sometimes we've done the application on the street car also. So we can then leverage the knowledge we have already from the engine and the application. And because of the similarities, you can carry over sometimes things also.
Okay. All right, let's move on, because I want to focus on your own KP Starlet. It's a work of art, and before we get into that, I want to sort of talk about the European Hillclimb Championship and how that works. I mean, I've seen videos of rounds of the European Hillclimb Championship, and the caliber of the cars and the competition is at just another level compared to anything else I've really seen, maybe short of Pikes Peak. But for a start, give us a high-level view of that European Hillclimb Championship. Whereabouts in Europe does it run? How many rounds are competed in?
Yeah, so actually it's very interesting. The European Hillclimb Championship is the oldest running FIA championship. So it's older than Formula One. Wow. And it has really some races that has been organized since the 40s, 50s. And when the first championship was run, I don't remember the year, but like I said, Wikipedia will tell, but it's older than Formula One. And it's typically 10, 11 rounds around Europe. So you go to Spain, Portugal, you go to France, you go to Italy. There used to be a race in Germany, not in the latest years. Poland, Slovakia. There's it's all around Europe. And what is also very nice with the European Hillclimb Championship is that it allows different kind of cars, pretty much everything. So we have the category 1 cars, like the regular tin tops, and then the category 2, which are the open wheelers, foamless prototypes. So there's such a variety of cars.
What sort of rule set are you working to? How stringent is it? How much flexibility is it? Because again, I've seen some of the cars that compete, and there's a wide variety, and it doesn't seem like they're built to a very strict rule set.
Yeah, that's exactly. It used to be a little bit different. Some years ago, you needed to have like an homologated. If you were in category 1, you needed to have an homologated car. So like a Mitsubishi Evo would do, or some Group N, Group A car, whatever. But now, just a few years ago, this new performance factor was launched. So because there was not enough people anymore participating in the championship, they thought, okay, because the national championships are full of cars which are not homologated but would fit here. So they thought, okay, we should maybe align up and make the rules common for everybody and introduce something that we can put these different national category, national, let's say, rule base may be slightly different in Germany or in France or in Poland. So this performance factor actually takes some things from the car, which calculates then a factor and puts you in 5 different groups. So the classes are not displacement based, but you put some key information from the engine, like individual throttle bodies or single throttle body. Is it dry sump or not? What's the maximum RPM? What's the displacement? So it gives you a factor for the engine. Then you have like chassis, what type of a chassis you have, what kind of structures you have, what kind of aerodynamic things you have in the car.
Oh, wow.
And finally spits out this factor and 5 groups. That's where you can drive with pretty much anything. The rules itself are for the safety quite strict. So everything what has to do with the like your seat, belts, fuel cell, fire extinguisher system and so on. So these are really, really strict, obviously. But like the modifications in the cars can be really, I mean, the engine is free and you have some limitations like, okay, you cannot move the firewall. So the firewall has to remain in the original place, but you can change the engine. You can make space for a bigger transmission. You can change your suspensions completely. You can put a all carbon bodywork. It's not a problem. And yeah, aerodynamics are also really free.
That's a really interesting concept with the performance factor. And I like the way that would breed a lot more freedom into the builds that you see, which obviously is why we see such insane cars competing. I'm always interested, having come from a local race series here, which was parity matched across a range of different engines. And at the time I was involved in the tuning of those and gaining parity. And of course, naturally, everyone starts complaining because someone else is faster. So I'm interested, how does that performance factor work out in terms of, does it breed nice competitive racing? How many people are complaining that the performance factor is wrong or they've been disadvantaged unfairly?
Yeah, that's quite normal, actually. It's the in the actual European Championship races itself, it's not a problem. People understand that we are here. I'm there racing with my Starlet because of the performance factor. So for me, it gives an opportunity to do really on the European Championship level racing with my old home built Toyota Starlet against some GT3s, Lamborghinis, Porsches. Like there's variety of factory built proper race cars here. But in these national series, like here in Germany, like the KW Berg Cup, which is been always the displacement based classes, and they have built over the last 30, 40, 50, I don't know, 100 years the cars to the Volkswagen Golf Mark 1s and 2s and Scirocco's, Polos, whatever, exactly for that specific rule set. And now they need to change the performance factor. So there's a lot of resistance on the changing.
Yeah, I mean, I think worldwide displacement-based classes are generally the norm. And I mean, I guess within reason, you know what you're dealing with because you only have that one rule. Obviously, there'll be other rules, but when you're building a car, you sort of select the class that you want to compete in based on your displacement and build the car to suit the performance factor as you've just explained it. Is a lot more all-encompassing of every element of the car build, so a lot more complexity. But with that, I would imagine, it sounds like I'm right, that it opens the door for a lot more complaints around the fairness of the performance factor.
Yeah, sure, but it also works. I must say, it works. Sometimes you're thinking that I'm against this Mitsubishi Evo with 700 horsepower and turbocharged four-wheel drive with huge wings, and there's a GT3, like I said, Lamborghini or a Porsche GT3R or whatever, and you're against them, and I'm like, this is not right. I'm just an underdog here, with this old little car. But then in the end, when you look at the times in the sheets, the fastest factor, the PF1 cars are on the top, and then you come down to the PF5 with the slowest cars. And obviously there's such a variety of drivers too. So some drivers can perform well with the not so performant car, and vice versa. So this makes the mix, but I find it actually works quite well.
Always nice when it does work as intended. Let's talk about your Starlet. And I'm assuming that the Starlet was sort of a natural progression from, as you said, sort of rally sprints into hill climbs. If you had to start again with a clean sheet of paper, would you think a KP Starlet is the ideal car to start with as a base platform?
Well, yes and no. I mean, I love the little Starlet, but honestly, now I've been driving with this car for over 20 years. It was 2002 when I started the project in the school final thesis thing I built from the car, and where it has ended up, it's been just continuous development and improvements over the years. I can't change it anymore. I feel like if the car is in running condition, I keep on working with it and tinkering and making it faster. But if I would start from fresh, I would possibly pick something else right now.
What would that something else be? I mean, particularly a base platform for being a competitive hill climb car. Would you be looking at something four-wheel drive instead of rear-wheel drive? Would you be looking at an open-wheeler sort of wings and slicks style, or what's the ultimate as you see it?
Yeah, I mean, it really depends on if you're only from driver's perspective, then you might want to go for a factory built, let's say, car, and then maybe tune it a bit more for hill climb, maybe a bit more power, something which is already a good chassis, a roll cage, suspension, brakes, everything set up properly, and you could start from there. Like an old Cup Porsche or something like that would be possibly good. Or you take an Mitsubishi Evo or whatever they have been in rallies, in circuit racings and things, so you can get a good platform. But I'm also an engineer, and I like to challenge the fact that with the old chassis, where you have like really still some fundamentals from the old design in the 70s, like the solid rear axle, you have the McPherson suspension in the front. Like, how can you make this type of a car to go really, really fast? That's also a challenge, and I like that. So
let's start with what you've just mentioned there, the solid or live axle in the back of the Starlet. Obviously it's a pretty common scenario for rear-wheel drive cars around that era. It's workable, but in comparison to the unsprung weight advantage of independent rear suspension, plus the control you've got over the suspension kinematics, depending how that independent rear is designed, how much of a disadvantage are you at with that solid rear end?
It's really difficult to say. I mean, if I would switch to an IRS in the car and got it finally working, tuned and so on, then I could say the difference. I don't feel it is that big of a difference anymore. Obviously, I'm not running an old Toyota rear axle anymore. It's something which is purely for motorsport, really lightweight. It's everything, really the kinematics and so the dampers things have been tuned over the years, so it works quite well. And especially from the start line, it's sometimes in these short courses, it's really important to get the car from the line. So like if I compare to these factory built, really more powerful cars, I can get the car really well from the line, and then I mean the acceleration is good. Obviously, sometimes in braking, cornering, you have some disadvantages that possibly the independent rear suspension could be better and an improvement, but it's not that bad.
Okay. You mentioned that it's a specific motorsport differential that you're running. What specifically is it?
Yeah, so I have a Winters quick change axle,
Okay.
which is basically a magnesium center, 7-inch ring and pinion, has the drop gear on the back, so I can quickly change the ratios, which is really, really crucial in hill climb courses because the difference on the speed requirements from the courses can vary so much. So has some floating axles, gun drilled, really light, again, aluminum hubs. And yeah, the axle, when I switched over from the old Toyota axle that I had, I saved like almost 20 kilos on the rear axle from the Corolla style.
Wow, that's a huge saving.
Yeah, that's huge. So, but like I said, it's magnesium. It's everything as light. The ring gear is machined from the back, basically hollow, and like it's a nice piece. So Winters does these for sprint races, and I guess it's used in the midgets, this 7-inch version behind a V8.
What about in terms of the differential itself? I'm assuming you're running a clutch plate style limited slip differential.
That might be a surprise, but it's actually a spool.
Wow. Okay. So for those who maybe haven't heard those terms before, the spool is essentially solid. So there's no differential action. Both rear wheels are locked together, so they both turn at the same rate. Now, I mean, that's not uncommon in a lot of forms of motorsport control classes, that they run a spool, and it simplifies things and the playing field's level for everyone. But as I understand it, not having raced a car with a spool does create some potential problems in terms of handling, and more specifically around the car's sort of not going to want to turn into a corner so much because the rear wheels are turning at the same speed. So does that create challenges in terms of driving style or car setup?
Well, yeah, definitely. It changes, but I used to run these clutch type limited slip differentials in the old axle, so different versions of them. The last one I had was the Casco one, which worked really nice. And I was thinking that, okay, because winters doesn't really offer anything what would suit my application for as a limited slip. So they have like those wedge locks and whatever things that are not really proper motorsport limited slip differentials, because they race in basically in the sprint races in the midgets with spools also. So I thought, okay, I will try it out how it works. And because of the nature of the little Starlet, it never really suffers from any understeer. So the car has always had a tendency to have it's tail happy, it oversteers. And I was thinking, okay, also how the car is still a bit, it's not a circuit car, it's a hill climb car. So maybe it's in between a circuit car setup and a rally car. So there is quite a bit of body movement and things. And I was thinking about how much it will push. And when I turn in and go to throttle, if it starts understeering or causing problems. But actually, if I compare it to the setup that I had in the Casco, which was also with quite high preload, and it was also locking really aggressively, the difference is not that big. So It's very drivable.
All right. I mean, if it works, it works. And in terms of the rest of the car, let's sort of move to one of the more interesting elements, which is the engine that you've got in it. And as I understand it, you've gone through a bit of a progression. You started with the old pushrod 4K and then went to a 5K. I think you've had a 4AGE in there as well. And most interesting, tell us what it's running now.
Yeah, so it has now the little Hayabusa-based V8 from RPE. So this is the version they use in Radical SR8. It is a very lightweight little V8, which in the end, when I was thinking about from the 4AGE, I knew, okay, there was not much more I could achieve, no matter how much money and time I would spend. And I felt that the car is not really in its final form, so I want more power. So then I started looking at options and figured out the little V8 being so small, and the RPE version is a 72 degree, so it basically is really narrow, so it allows you to put the engine between the frame rails and get the exhaust very nice setup even in the Starlet chassis, and sits low and back. So, and it's all in all lighter than the 4AGE was. So the front axle is better balanced because of the symmetry of the V8, and it's a few kilos lighter too.
That's absolutely insane that it's lighter than the 4AGE. Let's just come back to the 4AGE for a moment. You said you sort of got to the end of the development with that, and there was sort of nothing more you could do with it. I mean, obviously, anyone who's a Toyota fanatic would know of the Atlantic spec 4AGE, and we've talked about this previously on the podcast, but these engines were sort of, depending on who you talk to, 240, maybe 250 horsepower from 1.6 litres naturally aspirated, and sort of 10, 11,000 RPM rev limits. How far did you push the 4AGE development? Did you sort of go down that Atlantic path, or was that too extreme?
No. I think I went a little past beyond the Atlantic spec. So it's obviously when you talk about 4AGEs screaming 10,000 RPM, they're like, yeah, there's going to be an Atlantic. More or less, the Atlantic was a specified spec for the series run in North America. So it had a crankshaft, rods, pistons, cams, the modifications in the head, the typical TRD intake setup, and so on. And it was a powerful 1.6 liter engine, no doubt. Dry sump and so on. But I did not want to, let's say, try to acquire an Atlantic engine. They are really expensive and so on. But I started with a clean sheet of paper and thought, okay, I want to see what I can get out of the 4AGE, and really more or less didn't order any parts from the shelf or from the catalog, designed the things, and then ended up getting, let's say, quite good numbers. And yeah, I was revving it to 11,000 RPM. Actually, the hard limiter was like 11,200, and it was constantly with the gearbox and the ratios and the things I'm running between 7.5 and 11, and you can see it in quite many videos in YouTube actually too. So there's not so many that people claim, okay, my 4AG revs to 10.5 or something, but to really make power, to, let's say this engine had peak power at 10,300, and the power didn't really drop that much on 11,000. So quite an achievement from the old cylinder head and the engine design. Yeah.
Absolutely. What sort of horsepower numbers was it producing?
253 horsepower.
Wow. Okay, that is exceptional from a 4AGE, particularly as you mentioned, not using any of the Atlantic parts.
Yeah, with pump fuel also.
And with pump fuel. What was the reliability or sort of maintenance schedule for that engine? Because that's the other thing we hear with the Atlantic spec engines. Yes, they made the power. Yes, they revved as high as they did, but also they require fairly regular rebuilds. And I'm guessing the element that probably plays into your favor with hill climbing is you're probably over a weekend, you're not actually putting that many miles of use on the engine compared to circuit racing, correct?
Well, that also really depends. I mean, there are some races where I can do 150 kilometers with the car over the weekend.
Okay, I take it all back.
Yeah, I mean, it might be that I'm only full throttle for, let's say, 60 kilometers, and the rest is driving back and going around and doing things where you basically need to go from the paddock to the start line and so on. So sometimes these can be quite long distances too. So it's not necessarily that little, but okay, in general, the hill climbs are shorter. And yes, the maintenance really, for me, because I was anyway working on the engine, trying to always find new things. I was testing, and I never really pushed it into the point that I would see how long it really survives. So I rather, checked, opened up, and made sure that it is all in good condition. But I would say that you can do a hill climb season with this kind of power level and RPM range that I was running it.
And what, after that season of racing, what would be the service items inside of the engine? Is it a case of replace the entire rotating assembly, or is it, a light hone, re-ring the pistons, freshen the cylinder head, and it's good to go again?
Yeah, I mean, I've opened the engine a few times when I thought, okay, since it's open, I would change everything, but I stopped doing that. And actually, you don't necessarily even need to change the bearings. But again, these were not full seasons of the racing, just some reasons to open up. I also had some issues with things like pistons failing and so on. So, but now last year was finally the last year that I raced the engine. I had basically no issues at all with the engine. So,
so you got it to a point where it was reliable, and then decided to go to a different.
Exactly, yes, exactly. And it's still waiting there in the workshop to be checked. But it was running perfectly when I stopped and pulled it out of the car. So I will see then. But yes, the crankshaft has been the same. When I started 2016 with that engine, I built it for Pikes Peak. Originally, that was the first race with the 4AGE in the car. Crankshaft is the same. Rods, I had 2 sets made, and yeah, I survived with the rods. And pistons were the biggest, let's say, part of the puzzle to get them handle and hold and work. And then obviously, because of the combustion chamber, the design is not that easy to get a really high compression ratio. So to get the dome design and the deep enough valve pockets and things sorted out so that you can get the cams needed and the overlap and the things.
So everything becomes a bit of a compromise.
Yes.
In terms of compression ratio, but also fitting everything into the combustion chamber and clearancing the valves.
Yeah, but like cylinder head had few little issues, but these were more or less because of obviously there's so much work in the cylinder head. We had a crack in one exhaust port at some point which needed to be welded, but otherwise I had never a major engine failure with that.
Awesome. That's amazing. All right, well, let's move on to the current engine, the RPE Hayabusa-based V8. So obviously you can't buy a Hayabusa V8 from the factory. This is all aftermarket, basically using the Hayabusa cylinder heads and barrels, as I understand, with a bespoke crankshaft and block. What sort of power and RPM range does that Hayabusa V8 give you?
So far, I mean, there's some graphs even on RPE's website. You can see they offer the 2.7 liter, which has like 410 horsepower, goes to 10.5. The engine that I have now in the car, I have actually 2 engines. So the one in the car is the very early specification RPA, engine, which is a 2.6 liter version. It still has the 63 millimeter stroke, which is the Hayabusa Gen 1 stroke. It has original Hayabusa conrods, pistons, heads, cams, everything. Heads are not worked, nothing. It's basically two.
So it's basically stock except for it's been made into a V8.
Exactly, and has a dry sump system and so on. So some advantages, obviously. But this engine has hours. I don't know how many, but when I got it running and did the initial calibration, I was able to get 345 horsepower at just under 10,000 RPM, so 9.7 or something like that.
When you say that number, am I right in assuming that that's measured at the rear wheels?
No, this is the calculated.
That's a flywheel figure.
Yeah, calculated flywheel. Okay. Yeah. So a little bit less. I guess the original spec, they said like 380 for that first generation. But from a Gen 1 Busa, I mean, 190 from a Gen 1 Busa is maybe a bit too much.
Either way you look at it, a massive step up from the 250 odd horsepower you're at with the 4AGE anyway.
Sure, yeah. And I mean, the torque it's still a high RPM or high revving engine, so by nature, so it is already quite nice with the original heads and cams. I mean, the torque curve is pretty flat. It's only 275 newtons, but it starts from quite early and very easy to drive. Response is good. Like it revs to 10.5. But honestly, I don't really want to push it too far. So it's been around 10.2 what I've been revving it to. So, but the later ones, the RPX, the second engine that I have is a 2.7 liter. So with the stock 81 millimeter bore, it has the 65 millimeter stroke. So 2.7 liter. And with the, I guess they have this as an standard version at the moment with the Gen 2 heads and cams and things. It's like 410 horsepower what it has in the radical form.
Okay, that's a significant step up. In terms of sourcing these engines and parts for rebuilds, and you mentioned the Gen 1 engine is running all factory Hayabusa parts, so I guess that makes things nice and easy, but can you purchase components through RPE, or do they not really support the engines outside of returning them to base for rebuilds? Yeah,
well, their business model is they sell engines as complete kits. Comes with an wiring harness, ECU, calibration, which is locked, and if you install it with the instructions they have in whatever car, and then you run it and do the service. I guess it was 40 hours what they give for the standard interval. And if you let them service it, it has some sort of a warranty. But I asked for an offer for a new engine, but exactly for the reason that I would like to switch the ECU and do my own.
Yeah, you wouldn't want to be running a locked calibration.
No, and obviously I'm also interested in the tuning aspect and finding how I can make more power and modify it later. So eventually it was not an option for me to buy, and also it's actually quite expensive. So then I thought, okay, I need to source a used engine, and because if you don't buy an engine, you can't buy spare parts. And even, I guess, if you would buy an engine, they wouldn't sell you a crankshaft because they would like to repair the engine for you. So I ended up buying two engines just for the sake that I have spare parts.
Yeah, okay, that makes a lot of sense. In terms of the calibration side of things, I mean, still a relatively straightforward engine, correct? A port-injected, naturally aspirated V8. You're not dealing with variable cam control or anything too exotic. Were there any challenges involved in the calibration element of the engine?
Yeah, I mean, the firing interval is a bit odd, so you need to understand what to calibrate for each cylinder. And
so this is an odd fire engine due to the, did you say 72 degree?
Yeah, but it's a flat plane crank, so there's unequal distances between the cylinders when you switch the bank.
Okay, so I mean, for those who maybe aren't following the, conventionally we expect an engine, most instances, there is an equal number of degrees of crankshaft rotation between each of the cylinders firing. as opposed to in this instance, it's not an even change in crankshaft rotation, is it?
Sure, yeah, exactly. That's you have to be able to calibrate the distances correctly, and but like you said, it's a quite standard layout. I'm running the original Hayabusa throttle bodies, but did an electronic throttle actuator to run the two banks from one actuator.
So converted to drive-by-wire from cable throttle.
Yes, exactly. But I still have the bank control individual, so this was something I could do with the ECU. It's not very typical that if you have two independent banks, then you have one actuator for such throttle bodies. So that was a little bit of a tricky thing to do.
Okay. In terms of knock limits, what fuel are you running on, and with the compression ratio that you're at, is the engine knock limited, or are you able to tune the ignition timing to achieve MBT throughout the rev range?
Yeah, no, it's not. We need to run with pump fuel, but you can get 102 octane fuel here in Germany from pumps, so it's not knock limited at all. I think the original compression ratio is like 10, maybe 10 and a half in the Gen 1 Busa.
Right, so it's not even very high,
No,
really.
no. It was quite straightforward and simple, and the tuning points in the engine operating range don't change that much. I mean, it's a naturally aspirated engine, still making quite good power, horsepower per liter, so it obviously has some points, but compared to like the 4AGE, it's way simpler to handle.
With the drive-by-wire throttle, obviously that gives you the flexibility of mapping the relationship between the accelerator pedal position and the actual throttle opening, and it's difficult to explain easily without the benefit of sort of graphics. But if we look at the airflow through a throttle body, it's really non-linear, and you get quite a large increase in airflow over the initial maybe 15 to 20% of throttle opening, and then the further you open the throttle, that airflow increase sort of tapers off. So, if you're tuning an engine under steady state conditions, maybe 5,000-6,000 RPM, and you look at the relationship between engine torque and throttle position, it's very non-linear. And that can, particularly with high-powered engines, make them a little bit more difficult to drive. So where I'm going with this is when you've got the benefit of drive-by-wire, you can change that relationship of accelerator pedal position to throttle plate position, and essentially make the torque output a little bit more linear relative to what the driver's doing on the throttle pedal. Do you do anything around that to improve the drivability or alter the drivability of the car?
Sure, yeah, that's really standard thing. Obviously, you have the other advantages like the pneumatic shifting, blipping on the downshifts, and launch control. You don't need to open the throttle fully. And here, even when we're talking about with Starlet, the traction control first, second gear, if you do torque management with let's say ignition retard and cylinder cuts, it's quite heavy. So I don't even need to open the throttle necessarily fully on the first gear, and the launch control uses also the throttle from the airflow side to help it. So there's many different things you can definitely have advantage with the electronic throttle control. And like you said, you can map the pedal to torque if you like. So it's not linear for the throttle opening angle, but if you know the engine torque from the different throttle positions, then you can instead target that, so the response will be more linear from the pedal.
In terms of other elements of the tuning, are you doing anything around individual cylinder trimming tuning? Do you run individual lambda sensors for calibration of individual cylinder tuning or anything of that nature?
On this engine at the moment, no, it's not really necessary. But like I said, I ran the engine as a two bank system, so has obviously lambda sensors on both bank. They run lambda control is independent on both sides. So and also the throttle position for the alpha N is from each throttle body from the both banks separated. So if there is any uneven balance on the mechanical side of the throttle between the banks, the engine will still run nice on both sides. So this is something which I guess is a little bit of a trouble on the original RPE system they have, and also the ECU. So, but I got that running pretty nice and smooth when the two banks work independently and on each own throttle body.
And I'm guessing here it's a pretty safe assumption you're running a Bosch Motorsport ECU in this.
Yes, I've got the MS6 ECU in the car. Together, that is the PBX90, the power box. I have a little bit older display, the DDU7, and yeah, there's the ABS M4, and what else? Yeah, I think I mentioned the pneumatic shifter, so that's something I've built myself from the compressor, the valves, the actuator is not a system you can buy. I picked up components from some industrial catalogs, and put it together. But the control is done then fully on the ECU. The MS6 ECU has a paddle shift control strategy built in.
Let's talk about the transmission. So what are you running there? Obviously, you've just mentioned it's paddle shifted, but yeah, what's the specific transmission?
Yeah, so I have the little Sadev 6-speed sequential, the inline version. Very nice light, but yet quite strong.
Is that a gearbox that was designed from the outset for paddle actuation, or did you move from a mechanical lever to paddle shifting?
Yeah, it has, as a standard version, it has a typical shifter, but Sadev also sells an paddle shift kit for this. But like I said, I ended up then hacking my own system together.
Well, I'm interested on that front. Obviously, there's a range of different paddle shift kits available from different manufacturers. We went with, I think it's MME from Europe for our 8.6 to paddle shift the Hollinger gearbox that we've got in that. But with the commercial options available, why did you decide to go down the path of making your own?
Well, it was again one of these things that I knew, okay, if I want a good system, proper one, it would be like Megaline, for instance, which is really nice piece. The kit is expensive. To buy a new kit was a bit out of reach. Let's say I thought, okay, I don't want to spend that much money, but because I've worked with these systems in many, many applications and calibrated them, I know how it needs to work. And it's again one of those things where I thought, okay, let's see if I can build this myself. So, knowing some basics about what kind of forces you need on the shifter to shift and how fast reaction you need from the valves and what kind of pressure and things you usually work with in the pneumatic systems like Megaline and so on. So I had a ballpark. And then some of the things are just simple math, like the actuation with the two-way cylinder is something you can find some quite nice cylinders just from like Parker, for instance. They offer some really simple, strong, lightweight, and fast reacting cylinders. And you can basically pick the bore sizes to get the required force with the pressure you have and so on. So it's not that complicated. And like I said, I knew the control side really well. So then for the valves and how to do that, I was quite quickly, first I wasn't sure if it's going to work. So I thought, okay, I will see if I can get away with this home-built system. And it seemed to work quite well. And now I've been running it for already quite a few years. So it's worked actually quite well.
I'm interested with the paddle shift system and closed loop shift control, which is monitoring the barrel position. So basically the ECU knows when the next gear is completely engaged. In theory, it should do a really good job of extending the life of the gearbox components, and particularly the dog rings, which are the bits that actually select the gear. And again, difficult to explain without the benefit of graphics, but if you are mechanically shifting the gearbox with a lever, then a lot of it comes down to gearbox life expectancy. A lot of it comes down to driver technique, and you can have two drivers that are equally fast in the car, and one will do 2 seasons of racing without needing to pull the gearbox apart, and the other driver is probably wearing out a set of dog rings every second event. When you go to the paddle shift system, it kind of takes a lot of the driver skill an input out of it, because ultimately you're pulling a paddle and the electronics are doing the rest of it. How has that worked out in your experience with gearbox reliability? Are the dogs looking like brand new every time you pull the box apart?
Well, this gearbox I've only serviced once. So I put it in the car 2016, the same time when I switched to the 4AGE. Pikes Peak was the first event with it, 2016. And actually last year I opened the gearbox the first time. Now, everything what you mentioned is totally correct, but it also assumes that the calibration and everything is working correctly, because it's not only about the engagement and disengagement positions from the barrel position, but like that you actually cut enough, you introduce the torque in the right moment and bring it back with the ramp that works, and that you don't, with the wrong calibration, with a paddle shift system, you can also kill the gearbox really quickly.
Yeah, absolutely. Yeah. I mean, the assumption there, of course, is that the calibration is correct. Just a couple of bits that I want to dive into that you just mentioned there, sort of the torque reduction and how that's done. So again, for those who aren't aware, if you're in a dog engagement sequential gearbox and let's say you're in second gear, revving through the rev range, and you're about to get to the shift point to go from second up to third gear. So the dogs are engaged and there's a back cut on those dogs which prevents them from coming apart. So that's stopping you jumping out of gear. But of course, when you go from second to third, you need to release the dog so that shift can complete. So that's where we require some kind of interrupt to the engine torque. Now, I mean, in the old days before the advent of electronics, you would see the drivers just apply pressure to the shifter and then lift off the throttle partially, and that's just enough to reduce that engine torque and allow the shift to complete. These days we do this electronically, and there's a variety of options. We can cut the ignition, we can cut the fuel, we can do both. We could electronically close the throttle. Can you talk to us about how you're achieving that and the pros and cons of the different techniques?
Yeah, I mean, there's many different things. Obviously, when you really cut, if you want to fully cut the torque, you don't ignite anything. So you don't do any ignition in that cylinder. But okay, with a PFI engine, you might have fuel still, or you might want to cut also the fuel, or you don't cut the fuel and you may have a little pop on the shift. That's one thing. But the key is exactly that you do enough torque reduction really quickly to disengage the dogs and get basically the barrel rotating and the moving the dogs. So yeah, I'm not cutting completely. With the calibration that I have right now, I only do ignition retard and still keep my injection because of the wall film, and I don't want to cut the injection necessarily, because I can retard enough to get the torque reduction needed to disengage.
So you're only using ignition retard for the torque reduction?
Yes, but sometimes depending on the ratios, depending on a little bit things, I feel that the first to second shift, for instance, it's quite tricky. So I have been also cutting completely. So, but still keeping injection, but just cutting ignition. And then eventually when the shift is in a point where the next gear dogs are just about to engage and you start introducing the torque back again. So then obviously you don't bring the torque fully back immediately, but you have a very retarded ignition and you slowly bring it back. Maybe you have a little step in the beginning and then you ramp it back. So
okay. I'm just interested if we can maybe put some specific numbers around this, sort of how much ignition retard do you find you need to get sufficient torque reduction for the shift to initiate?
Well, typically you're around like 30 degrees after TDC. So
okay.
30 to 40. Sometimes maybe 25 is enough, but that's a bit risky. Like 20 to 25 to 30 is maybe on a range of a bit risky, but like 30 degrees, 32, 34, 35, then for sure you have already.
And just to be clear, you're talking degrees after top dead center, not the amount of retard from the normal wide open throttle running timing.
I'm talking about the absolute ignition time after TDC.
Okay. All right. So then once that shift is completed and you're monitoring that barrel position, so the ECU then knows when that next gear has properly engaged so it can start reintroducing that torque. So you've mentioned that you don't want to reintroduce that torque too quickly. And you're going to blend that ignition timing back into the normal timing over a certain period of time. How long are we talking here? Is this sort of 50 milliseconds, 500 milliseconds?
Yeah, so if we're talking about a pneumatic system which is, let's say, working properly in these typical GT applications, and also where the SADE with my home built pneumatic shifter is. A first to second shift is obviously a bit slower than from fifth to sixth gear. But like on fifth to sixth gear, a good system with pneumatic or now with the electronic actuated gearbox shifter systems, they can do like 50 milliseconds to 60 milliseconds, a safe shift from and I'm talking about the point where you cut the torque to the point when it's fully back.
Right, okay, so that's really fast. So that's not the actual shift time, that's the entire shift process from initiation through to full torque being reinstated.
Yes, but you have to remember that sometimes the shift itself is longer, it starts earlier. You do preloading maybe on the pneumatic system, and then but from the point when the engine sees the torque to be reduced. So this is atypical. Let's say from first to second gear, I can shift like 80 to 90 milliseconds. And the cut is like maybe the first 40 to 50 milliseconds of it, and then the rest is the ramp, the torque back.
Okay. If you eliminated that ramp back in for your timing and just reintroduced full engine torque instantaneously that the next gear is detected to be engaged, is that a problem for the gearbox strength and reliability, or is it a problem for interrupting the traction or affecting the traction of the car as you go into that next gear?
So usually what happens is that if you're too harsh with it, first of all, when the docks engage again, you don't want to hit them too hard when they touch and they start sliding in the full engaged position. If you bring the torque really heavy back here, that's going to obviously hurt the docks. And another thing is the consequence of a really fast ramp back is also that you load the drivetrain again very quickly. So you start introducing oscillations and ringing, and you see that from the typically from the engine speed signal quite easily that there can be huge ringing after the shift if you're too quick and fast and try to bring the torque back. So you want to, let's say, load the whole drivetrain a little bit smoother. So it's basically for the whole, everything what is in the drivetrain, everything in the car. Yeah. It's just drive shafts, the final gear, like the ring and pinion, like the, everything what is involved. When you avoid this ringing, then it's just much, much smoother.
Okay. No, that makes a lot of sense. In terms of the calibration of that, is this something that you're really just doing by feel, making these changes and then testing to see how the shift progresses and what the feeling is, or is it based on data analysis or a combination of all of the above?
Yeah, I mean, the driver feedback is usually the shift is too hard or it's very slow, sluggish, it's not shifting necessarily smooth by whatever reason, but you can see it always in the data. And this is actually a point where what I mentioned earlier about the data logging capabilities with the Bosch ECU, you can log the gearbox signal with 1 kilohertz. Then you have all the engine-related signals like ignition, advance, and like all these states from the shifter and things in segment synchronous. So basically per cylinder. So you will see that what happens, how, and what happens really on the gearbox signal really well. And yes, when you have experience, you will see quite easily the problems from the data. And then another thing is like if you have a car, like a turbocharged application, which is in some spec regulations. You have some BOP things like boost limits, and you have to respect them. So then you have to also make sure that when you do the shift, you obviously will cause in other systems some influence, and you have to take care of these things too.
So you're talking here about the boost control across the shift as well, making sure that you don't exceed the boost limit.
Yeah, and that you don't drop too much, also. So there's many different things.
Yeah, that's an element, obviously, with the turbocharged engine. Conventionally, if we shift and lift off the throttle and use the clutch, you're going to drop completely off boost, and then it takes a period of time to come back. The benefit of a dog engagement gearbox is we can shift at wide open throttle. So I think people expect that a turbocharged engine will have a nice, perfectly flat boost curve across the shift. Of course, we're still removing exhaust gas energy from the turbocharger if we're using a cut. So there will be a drop off in boost. So it's about getting that gear shift as fast as we can so that we retain the boost pressure as much as we can, correct?
Yeah, or actually, if you only retard, then you may cause a jump.
An overboost.
If it's calculated like you can't go 5 millibar over or you're disqualified. So that's for the controller. Yeah.
So care is definitely needed around that calibration. All right, look, Mikko, we've gone pretty deep down that rabbit hole, but I will start towards wrapping things up because we are going a bit long here and I want to respect your time. So we'll finish up with the 3 questions we ask all of our guests. And the first of those is, what's next in the future for you? Specifically around the KP Starlet, is development finished, or is this an ongoing project that will never be finished as long as you're driving it?
Exactly. Last 20 years have been continuous development. I don't think I will stop now. So obviously the engine is new. There's still tons of things to fine tune and tweak to make it really drive and behave and be fast. I have the number 2 engine still in, so I'm building this number 1 engine now. So let's see how much more power that will be then eventually. And yeah, obviously there's now so much more power. So I recently started adding some aero elements like a big rear wing. So definitely it's going to need some more time on the aero side. It's still an old 80s Toyota Starlet, so it's
not the most aerodynamic shape out of off the factory floor, right?
No, exactly. And there's definitely some things I want to address with the cooling. The radiator is in the front. I would like with the V8 to work a bit more on the plenum, to direct the air into the plenum to have the airflow for the cooling system and everything. Possibly I will move the radiator to a completely different location, and then I have more freedom in the front. There's so many things.
Okay, sounds like a pretty long list of potential upgrades in the future.
Well, we're talking about the next few months for next season.
Okay, well, best of luck with that. Next question, is there any advice you'd give to a younger version of yourself to help you reach where you are today in your career faster?
You have to step out of your safe zone. Let's say be a little uncomfortable. For me, coming from Finland, like we speak obviously Finnish in Finland. We have Swedish as a second language. We learn English usually in the school, and now I'm in Germany working for a German company, and I have to learn German on an, let's say, older age when it's not that easy anymore. So
bit of a challenge there.
Yeah.
Well, I can guarantee it would be easier being based in Europe to get exposure to multiple languages than it is here in New Zealand. And if I look back at my schooling, I absolutely sucked at foreign languages. I've got a bit of a mental block on that. It just doesn't work for me, doesn't compute. So I understand the pain of maybe trying to learn German at an older point in life.
Especially the grammar is so hard, but...
All right, Mikko, last question for today. If people want to follow your journey and see what you're up to, how are they best to do so?
VHT Racing. It's in Instagram, YouTube, Facebook. Yeah, there's tons of videos, pictures, things. But unfortunately, only from the journey with the Starlet. So the professional stuff, I cannot really share usually that much.
Yeah, no, I totally understand. Normally, any of that sort of work is strictly held back with a bunch of NDAs. So yeah, it would be nice if you could share that, but I understand. As usual, we'll put links to your social media accounts in the show notes to make it easy for people to find. Look, Mikko, been great to chat and get some insight into your Starlet build. I have a special place in my heart for old rear-wheel drive Toyotas and had a KP Starlet of my own back in the day as a project car. So, you know, really appreciate what you've done to that car. It is an absolute work of art. And I look forward to seeing progress once you sort of dial in everything with the new V8 and get this aero on the car and see how competitive it can be.
Thank you.
If you've enjoyed this episode of Tuned In with Mikko, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Sean Taylor from the United States, who has said, hands down, some of the best, most informative automotive content out there. Great guests and knowledgeable hosts who dive deep and discuss all aspects of automotive and motorsports performance. The breadth of topics covered on this show is very comprehensive, and each episode is filled with plenty of information someone from any level of experience can appreciate. Well, thanks for the kind words there, Sean. Great to hear that you are enjoying the podcast, and if you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.